Okay, and then I'll share a screen. Okay, can folks see that okay?
Yep.
Yeah,
Okay, so welcome to the June 2024 meeting of the Seattle Robotics Society. I'm Lloyd. I'm hosting this one while Steve is out. He's got some type of conflict going on for the last couple of months and for the next couple of months. So Steve and Chaz, or excuse me, Chaz and I are taking over the hosting for a little bit. The video is provided by Zoom. We record all of our meetings. We'll post them on YouTube later. So below that, you see kind of an outline of what we're going to do for about the next hour or so, depending. And then about 11 o'clock, we'll start with our feature presentation. Please mute your microphone unless you're actively sharing. You can use the Zoom chat to ask questions, make comments, post links, anything else. That also gets recorded with the meeting and will be posted. Kind of already did this slide. Chaz and I are kind of doing the hosting for the next couple of months. Steve still is coordinating the presenters and updating the website. Steve does teach a kids robotics class. And if you're interested in that, there's Mr. Steve's Robotics Club at gmail.com. You can reach out to him. Past events. Oh, we got the Robot Combat League. And also last weekend, it's not on here, but we had a Robothon, or a mini Robothon. So folks, we had a pretty good attendance at that considering. We'll talk about that. I'll talk about that a little more when we get into Robothon. If you're interested in maker spaces, there's a few local maker spaces. There's Snowco Makers. The King County Library System has a whole bunch of wonderful maker spaces. I've been to the one in Bellevue. The one in Bellevue is really nice. Seattle Makers, Alt Space Seattle, North End Makers, Creation Station. Another one's not on the list. I was noticing yesterday, or excuse me, last week. If you happen to be out at the Super Mall in Auburn, they have it's not a maker space, but it's a spot where you can rent tools and such. So it's a tool library. Upcoming events. So there's a Robot Events website for national events. Snowco has regular meetings up at their makerspace. Looks like there's a Robotics Developer Day on 7/5. That's an online conference. I have that day off. I might want to check that one out. And there's some AI hackathon demos from July 27th to December. I'm not quite sure what's going on there. If you have an upcoming event, feel free to email Steve at Seattle Robotics Society at gmail.com. And we are talking about doing another virtual Robothon exhibition at some point as well. So if you're interested in that, also let Steve know. Robothon committee, we did a in-person event on June 8th. This was a mini Robothon held at the First WA field house. This is the new field house. They moved during COVID. Went pretty well. We had about, I think, at peak, there were about 30 people there. So given this, we used to do these at the Seattle Center, and we had people all over. So we're starting to do them more in local venues now and a little more focused group. So 30 was about twice the number of people we had at Sunnycrest Elementary last fall. So that, we're growing it back. We are planning to host another event at Sunnycrest. It'll probably be September, October. That'll be an outdoor event. Gotta check the weather. But that'll be an outdoor event with Robo Magellan. So keep tuned for that one. Again, if there's anybody interested in doing a virtual robot exhibition, these are what we did during COVID. And so it's completely virtual. It's just a series of between 4 and 6 little mini presentations where, each presenter gets about 20 minutes-ish to present on a smaller topic or a robot they're working on. Those did really well during COVID, and they kind of trailed off a little bit, so we started doing other things. If folks are interested in bringing those back, let us know, and if we get enough, we'll do one. Steve is also looking for presenters. You can present from anywhere because we're hybrid at this point. You're interested in doing a presentation, let Steve know at Seattle Robotics Society at gmail.com. If we don't have a speaker, we'll do the open discussion forum. We can always slot one of these in. If you're interested in facilitating one of these discussions, also let Steve know. And this is just kind of a list of ones we could do and people have talked about in the past. If you have something else that you're interested in, feel free to put that in there as well. So this list is by no means exhaustive. We do have a pretty good set of speakers coming up. Today we have Jon Davis on ChatGPT AI. Next month is Bernardo, Basics of ROS. I actually met him last week at the mini Robothon. Let's see. So August and September, we've got, looks like October and November are open. So if you want something in the short, moderate term, I guess we'll call that. October and November are still open. Coming up later today, we have Jon Davis, Enhancing Software Programming Productivity with GPT and LLM Tools. So we'll start that about 11 o'clock-ish, give or take a little, depending on how the around the room goes. I am going to have to sign off about 12 o'clock today, but if folks want to hang around, we can definitely do that. I'll pass the host function over to you. We will turn off the recording, and then people can hang out on the chat as long as they want. Okay, around the room, does anyone have anything that they would like to share? And Steve was kind enough to give me a couple of presentations here to fill in if we don't have anything. If anybody has anything, just go ahead and unmute your mic and go for it.
I just, I guess, based on the topic of today's presentation, ChatGPT, I will just point out that our open source robotics development environment with the simulated robot and all that good stuff has a ChatGPT interface in it. If you set up an account with them, there's an easy way to send it questions, and then it has some tools for parsing the result to get like code out of it or numbers out of it or whatever, which makes it a little bit more useful. And it's not quite in there yet, but we have a working physics engine now in the simulated robot. So a part of the IDE is a simulated robotic arm. And it allows you to write a program that moves the arm around and does things. We've always had the ability to put like blocks or whatever in the environment, and you could sort of fake picking up the blocks and moving them around. But in the past, if you let the block go, it would just kind of hang in the air. Now, you can set it up such that the block will then fall onto the table that the arm is on, or fall off the table. So that might be something that people are interested in just for, playing around with ChatGPT. We've recently done some work where we ask ChatGPT how to solve a particular problem, and it has been surprisingly good in like writing programs that can then just directly be run, or providing data to a program that can then run and actually get things done.
Well, yeah, I was gonna say we got some time, James. If you want to, I don't know if you got a little any type of demo, or just want to do a screen share on something. I can release the screen if you want to do that. And if not, that's totally okay too. Totally recognize I'm catching you, last minute here on that. So
Yeah, no, maybe we can set something up for the future because
okay.
I think the case could be made for doing a whole like presentation
Oh,
on
absolutely.
DDE and what it can do, especially the new features. And I might be able to get my uh, coworker Fry, who wrote DDE. He's an MIT professor. Um, he and his crazy hair might come on and maybe give a presentation. I'm talking to him about that. He's actually presenting again at the UN, at the part of the UN that's dedicated towards youth. So it's like the UN. I can't think of the exact name of it,
Oh,
but it's like
interesting.
there's a whole section of the UN which is focused on trying to inspire the youth of the world to do more uh, or to move in positive directions. And he has presented for them in the past and will present again, and so he might be willing to do that. Um, oh, and then one other really quick thing. My UCSD extension class that I'm teaching in robotics with JavaScript is for the very first time at full capacity, had 10 students on the waiting list.
Oh,
All
nice.
of my students are doing fantastic. And I just want to share that I'm super impressed that the youth are um, coming on strong. It's the
Nice.
first time in a while I've had some hope for the world.
Yep. Nope. And I'm having regular discussions with folks around that I work with and stuff of why can't we find skilled labor? It's becoming a real nightmare. Finding
I tell
people.
you why you can't find skilled labor. It's because guys like me go out and teach classes, find the skilled labor, and then snap them up before you have the chance. That's why you can't find them.
Ah, you may want to talk more about that. I may have to. That's an interesting. I hadn't thought of that.
It works that way too. It really does. You would not
Yep, that's
believe
a
some of the
good
people that
thought.
we've found.
I think I may take that up with our consulting group because it's like I know there's smart kids out there, right? I run across them occasionally. We just can't find any to hire. That's interesting. Okay, do we have anyone else who would like to share something?
Lloyd,
All right.
this is Greg.
Oh,
This is
Chris, go ahead.
Greg. Just a little self-promotion. I just put the link to my YouTube channel in the chat. I've got videos up there of Gidget, 2 of her 3 runs and the Pop Can Challenge for
Oh,
anybody
awesome.
that's interested in seeing how that went, at least from her perspective.
Nice. Remind me on that, and I will put those on the SRS and more page as well. So we can do that as well for and promote them that way a bit.
Yep. Okay.
Okay. Anybody else have anything?
Can I just congratulate Greg and say that I absolutely love the thing of turning the can sideways after you pick it up. That was freaking great.
Well, that was to overcome a problem she had in the last contest where the can kept slipping out of the gripper.
Yep.
And it was funny. After that contest, but before this one, I had an opportunity to go speak at a middle school to a couple robotics STEM classes and to their after school robotics club. And I took Gidget and I talked about some of the challenges that I had encountered, and I mentioned that one of them was, the fact that the can would slip out of the gripper, and I asked them, now how might this be solved? And they had some good ideas, some of the obvious ideas, put another finger on it or put something underneath that held the can from underneath, so I let them kind of throw those out there, and then when they were done, I said, but I think what I'm going to do is I'm going to have her twist the can, and you can see their eyes kind of light up like, none of that. Well, yeah, that's why she did that, was just previous runs, the can would just slowly slip out and hit the floor. So thank you.
Yep, simple solutions. Hey,
Depending on how vigorous your motor can turn, you could also have it shake the can.
I thought about doing that, and somebody else suggested the same thing. A little attitude before putting the can on the table.
Yeah, it depends who it's fetching it for.
Exactly, and whether Gidget is a 8-year-old or a 13-year-old.
Or maybe it depends on whether or not she's getting a can of soda for the guy who's saying, "Not that far. Why did you go that far?"
Yeah, exactly.
well,
Don't know who that is.
tell you what, Greg, if you want to do we could just run one of those videos now if you want to.
Sure.
Let me see
You
if I
want to
can
do that?
Yeah, you're a little choppy. I don't know if that's your microphone or your internet connection. Let me just see if I can grab one of them here.
For those that don't know, Gidget is the high-level, kind of the supervisor runs a behavior tree. And if you've done any reading about behavior trees, the two use cases they always explain are robotics and NPC, non-player characters in video games, to kind of give them the illusion of, intelligence. That's what Gidget uses to kind of do that high-level planning. There was somebody at the meeting or at the contest on Saturday that he was looking over my shoulder as I was making tweaks to that and said, "Oh, you're using behavior trees." I had to turn around and say to him, "You're the first person that knew what behavior trees was." But he works at some local robotics company that's developing robots for agriculture. So apparently they use behavior trees for that.
Oh, cool. Hey, is there one of these that's really good to go? I see there, it looks like there's
That one's fine right there.
the first one. Okay, we'll do that.
Yes. Well, let's see. Is that run 3 of 3?
Yes,
I
it
mean,
is.
either. So Gidget runs at, the previous attempts were all at 0.3 meters a second. And then after she did the first one successfully, I thought, well, let's crank that up. So then I had her run at 0.6 meters a second, but then on run number 2, which is not in this video here, but on run number 2, he approached the refrigerator at that speed and then crashed into the refrigerator. And that threw everything off. So then run number 3, he was at 0.6 meters a second, but for things like approaching the refrigerator, I had her slow down. So that's what this is. So this is run 3 of 3. He's moving a little quicker. Yeah, go ahead.
Okay.
This is just us doing a refrigerator swap there real quick.
So did you guys each use your own refrigerators that you had tested with?
Well, yeah. The other refrigerator, I guess, is the official refrigerator.
Jesus, what the heck?
This is kind of cool because folks that were there, you'll notice I'm sitting in the background on this one, so I couldn't see the refrigerator side. So now I get to see the refrigerator side.
So a behavior tree, one of the things you can do with the behavior tree is you've got all these nodes and they return one of 3 states: success, failure, or running. And in this case, she was too far to the right, so the node that was responsible for that returned failure.
Oh, too far
Then a
over.
node that caused her to back up was invoked, and then it retried that part of the behavior tree. So you can kind of you can put into your behavior tree kind of air recovery steps, things like that. And so at this point, she checks, she tries to determine where the refrigerator is, then plots a course to get to a certain point, then determines where the refrigerator is again to see if he's in the right place. As you saw, she backed up twice because she wasn't happy with it. She's happy with it now.
Pink. And out of the way.
Now she's kind of taking a picture, looking for the can, turning a little bit, taking another picture.
What are the sensors that you're using here? Is it all camera?
That is a real sense. Depth camera is being used for that portion.
So you're extracting the 3D data from it, which accounts for the pauses, since that's a lot of processing.
Yeah, yep. She just said,
There's
do
that
I have the can?
She doesn't have a. She doesn't know if she has the can.
And she doesn't have a sensor in the gripper to tell her she's got a can.
What are you doing all the way over there?
I just love this constant one-sided conversation that you have with Gidget as she's working.
Yeah, we've spent a lot of time together.
I wasn't going to make the commentary, but now I will. Kind of sounds like an old married couple. Nicely done.
She doesn't have a lot of margin for error when it comes to getting all of the robot into the 2 foot by 2 foot square, but
Okay.
1 meter per second.
Yeah. Oh, well, there's another Gidget one. This is a quick video. It looks like.
that's earlier in the development. I just wanted to see how accurate the RoboClaw was in terms of, distance. I had to go out a given distance and then back, and then I'd check to see how
2
far up it
meters
was.
per second.
That's Dead
Yeah.
Reckoning, or is that helped out?
Yeah,
with
that's Dead Reckoning, yeah. And that's not 2 meters a second. I don't know what I was talking about. But it's pretty quick.
3 meters per second.
No, it's not. I had my math off. I think her top speed is 1.7 meters a second.
Cool. All right. Let's see. Does anyone have anything else they would like to share? Okay. I've got a couple of videos here from the chat. So let me see if I can get those. What's going on here? Or excuse me, I got a couple other videos from the slide deck. How about this curious robot should be impossible? Sound good to folks? Oops. Okay, let me get. It's running advertisements. Hang on just a second, we'll get past that.
Only in theaters June 14.
All right, we'll get this set up. All right, hang on. I'm on my laptop here, so I've got to chase windows around.
What meeting?
Can folks see that okay? I don't know if the share pod or not. Hang on, I'm going to reshare. There we go. Now it's got it.
An incredible new robot that learned to explore, stand up, and even handle packages, and more. Now, wait a second. What you see here should be impossible. Why is that? Why is this impossible? Dear fellow scholars, this is 2-minute papers with Dr. Károly Zsolnai Fehér. Well, to understand what is going on here, let's look into the popular large language models first. You see, when training a large language model to understand English and be a good assistant, we can give it tons and tons of data from the internet to learn on. For instance, the early GPT-2 read Amazon reviews and learned to write new ones. This was possible because tons and tons of training data was available. However, this should be impossible for a real robot in the real world. Why is that? Well, have a look at this paper where scientists at NVIDIA tried to teach a software agent to run. And it kind of learned to run, okay, but after quite a bit of training. At first, it looked like this. Now, letting a robot loose in a lab while flailing around would not work too well because it would injure itself and its environment before any meaningful learning could happen. So, in software, there is plenty of training data to learn from, but for robotics, there is no data. None. Or, even if there is just not enough to learn anything. So, how can we solve this? Well, the solution is my favorite, which is learning inside a simulation. Letting the robot play around in a video game. Here, they are doing reinforcement learning, which means truly playing a video game. Here, you do something, and if you do well, you get a score, a reward. If you don't do so well, you get nothing, or a negative score. Now, we also need a little magic sauce here to make sure that the robot is curious and wants to explore and understand the world around it. Normally, that is not that difficult. For instance, DeepMind's agents can play video games as they are yearning for a high score, so they will go around and explore. However, there is a huge problem. A TV problem. Yes, you heard it right. The AI has a TV problem. Agents like these can encounter a TV in a virtual world, and then this happens. Yes, they get addicted to it and they never want to leave. Now that is real human-like behavior if I've ever seen one. This happens because the agent is getting new information all the time and it's much more interesting than these otherwise boring levels. So, how did they make this little robot curious? Well, by engineering the rewards of the game in a way that, for instance, if the angle or the velocity of the door changes, it gets a reward. Thus, look, it starts experimenting with it. Now, new task. If we wish to get it to move boxes around to where they belong, we can craft a reward involving the velocity of the box and the distance from the container. Now, hold on to your papers, fellow scholars, because this is the moment of truth. Let's jump from the video game world into the real world and see how this little robot fares. And, whoa! Look at that! It can navigate around in the real world competently, and it can even stand up. It now opens those doors and can handle packages. Well, as you see, it handles them at least as gently as some of the delivery services out there. Another human-like trait. Perfect! Now, jokes aside, by further tailoring these reward functions, I would imagine that it could be much gentler with those packages and even doors just one more paper down the line. And also, bravo! What has been achieved here is extremely hard. Why? Well, because we cannot just make a simpler video game for this robot to learn on. It has to be good enough to even work in the real world after all. And if the knowledge from here does not translate properly to here, things can break really quickly. This was an amazing feat. And just imagine that now we have better and better tools to create virtual worlds. A lot of our episodes are on new papers that improve these potential simulation environments. And every single one of those could be one step closer for us to have these little AIs train in these virtual worlds and then come out into the real world, help us out, and do all this safely. For instance, these little robots could help us with last mile delivery. The idea behind this paper could also help us create better self-driving cars that can safely train in an environment where we can make crazy hard levels for it and with a powerful computer have it train for years and years in computer simulation time, not in real time, and then come out as a safe and competent AI agent. What a time to be alive! And this is not science fiction, not at all. In an earlier paper, we saw NVIDIA's AI train for 33 years in simulation time to play in Minecraft, and boy, did it learn a great deal in there. Now, this new work, of course, does not come without limitations. Hand engineering reward functions is a bit of a limitation here, which means that we have to write these rewards ourselves. So, if we need it to perform a new task, it needs a new reward function for that, limiting the generality of the agent. An earlier paper we talked about here could potentially remedy that, as it is about teaching these AI agents to find out what a good score would be. Experiment tracking, model evaluation, and production monitoring for your deep learning projects and LLM apps. This is what Weights and Biases does, and it is the best. Everyone is using it. Try it out now at wnb.me/papers or click the link in the description below.
All right, whoops. Okay, well, it was entertaining. Let's see, does anyone, oh, I saw looked like somebody had a hand up or something. Oh, James, yeah, the thumbs up, okay. So we do another one? Let's see what I got next. I'm kind of curious to see this flying a helicopter on Mars one, so let's try that. Get that one set up. Whoop, hang on.
Is the moment that the Ingenuity helicopter made history, making the first ever powered flight on another planet.
It will tell us whether our understanding of how we fly is correct. So that's the first thing we want to discover. Can we fly on Mars? So we think the math says we can. Our understanding of basic principles say we can. With difficulty, but yes, we can. Now this will be the proof.
290 million kilometers away, NASA's Ingenuity helicopter has taken the first step towards a new type of space exploration.
We have been walking on Mars, and there's nothing wrong with that. You need to walk to discover, but now we can run.
Before the historic flight, Nature spoke with Dr. Anubhav Datta, who was part of the team that helped test the craft.
In terms of range, reach, and resolution, it's hard to beat an aircraft that can fly, and can fly at low speed in controlled hover mode. Particularly on Mars, the places that we're interested in are up the slope, down the crater, into the caves, on the cliffs. And so those are very inaccessible terrain, especially with no roads and rocky terrain on Mars.
But flying on Mars is far from straightforward.
Just to be able to carry a flying vehicle 292 million miles and deploy it, unfold it, all in one piece, still alive and beaming, that is an incredible achievement just by itself. We learned how to fly on Earth after 8 years of experimentation, trial, error, flight tests, wind tunnel tests, building special wind tunnels. So the first challenge is obvious, that we don't have that chance for trial and error and design, build, fly on other planets. So we have to rely on simulation and our very carefully scaled testing that we can do on Earth and extrapolate our knowledge.
But getting to Mars safely is not the only problem. Mars has a much thinner atmosphere than Earth, and that means that the parameters flight relies on, like the viscosity and density of air, are all different.
The fundamental ingredient of lift is what keeps airplanes afloat in air, is viscosity. And there is viscosity on Mars, so you can fly on Mars. How much lift you generate depends on density.
The Martian atmosphere means that scientists like Data need to think about design completely differently.
When you try to design something on the basis of viscosity with very low density, it's a new kind of design that relies on what is called Reynolds number.
Reynolds number is related to airflow, but it's not especially relevant to the design of large craft on Earth.
Some people interested in insect flight zoom into that number, but in big aircraft we ignore that number. But that number becomes the driving factor for Martian design.
Ingenuity's design had to contend with a unique set of challenges, different from those faced by craft on Earth. But to an aerospace engineer, these challenges also offered opportunities.
If you think in a different way, there are many advantages of flying on Mars. There's low density, means low drag, which means you don't have to shape the fuselage or the airframe in a particularly aerodynamic manner. So you can have science instruments sticking all around the aircraft. All you have to do is to let the rotor carry you to where you want to go. That's an enormous benefit.
Ingenuity's first flight, 3 meters up into the Martian air, followed by a 90-degree turn and a safe descent, may not sound like much. But its significance for the future of planetary exploration will be felt for years to come.
Sometimes people think, oh, it'll just pop into the air and maybe not go anywhere. Well, remember, for vertical lift and for helicopters, that's the most difficult mode of flight, the rock-solid hover. And so that's what it's going to try and attempt. So yes, it's a short flight, but it's by no means a simple flight. In fact, it is the most difficult flight. Oh, the implication is huge. So if we can fly and give a platform to our planetary scientists, an unparalleled platform to have access to all the remote corners and interesting features of Mars that they don't have now. So as I said, it's like we were walking. The last 25 years, we have had rovers. We have covered a total of 44 miles in total of flat, simple terrain. Now, all of a sudden, we are opening up this new space. For a long time, conventionally, aeronautics is the tax you pay for space research because you can't get to space or come back from space without aeronautics. But now it can provide a launching pad for new exploration in space.
Okay, so that's that one. Let's see, we've got We got about 10 minutes to go. Well, 5 or 10 minutes to go before taking a break. Does anyone have anything else, or should we try another video? Let's see if we've got another video in here that's good. How about the GR1 robot? We'll do that and then take a break. How's that sound?
I'm going to give away this incredible $4,000. Wait, no, not this one. This.
Not seeing the share there, Lloyd.
Yep, hang on a sec. I am getting it. How about now?
There it is.
And by the way, it looks like this is the same camera or same 3D cameras on Gidget.
Correct.
Well, that was entertaining.
Can I rant for a minute about that one?
We got a couple minutes. Let's go ahead and do this one too. At the same time. All right. Let's see. Okay, that if we do about a 10-minute break, that'll get us right to about 11 o'clock. Or excuse me, yep, 11 o'clock, and that'll be just about time for the presentation. Okay, let me get a 10-minute timer started up here, and folks can hang out and chat, do whatever you'd like. I'll keep the video, or I'll keep the recording running. If you want to step away for a couple minutes, feel free, and we'll be back in about 10.
Hey, Greg, are you willing to answer a question about Gidget and your 3D scanner?
Yes.
So what are you actually doing to extract data from the massive cloud of information that it sends back? How are you doing that?
Well, I'm not using object detection. I'm doing color detection. So the first thing that it does is it takes the RGB image, and then using OpenCV, finds that region of red within that white interior of the refrigerator. And
Okay,
once it,
so that's when you're finding the can, are you not using the camera like before that when you find the refrigerator, when you find the edge of the refrigerator?
I am using a different sensor for that.
Okay.
It's called I think it's called a MetaSense. It's a 100 by 100 pixel time of flight sensor.
Right.
So it gives you that 2D array of distances. Now, I'm not using it as a 2D array. What I do is I take like the middle 4 rows and average them so that I get a one-dimensional array of distances. So it's kind of like a poor man's LiDAR in a sense, right? So I've got this one-dimensional array of distances. It's you can vary the resolution. It's only 8-bit, but you can set it so that each bit represents from like 1 to 9 millimeters. So with 8 bits set to its lowest resolution, 9 millimeters per bit, you get about 2 meters of range. So it uses that when it's far away from the refrigerator, estimates where that left front corner is, moves to that point, then reduces increases the resolution. It takes another picture and then reassesses. And that's why the refrigerator the door is white, because the black paint appeared to absorb infrared. The problem with the real sense, or those stereo cameras like that, is they need some texture or noise in the image to do what they do. Now, unlike the Microsoft product, which relied on a projected infrared noise, the RealSense doesn't. So you can use the RealSense outdoors. But when you're looking at something that doesn't have much surface feature, it can't derive the depth information. So you can tell it to turn on the infrared emitter to put a texture on that surface. But then when I did it with that refrigerator with the black door, it was still a void in the depth information. It could not see the front of the refrigerator with either of those two sensors. So I took the door off and painted it white.
This is what we've run into this so many times. The main thing that I can say about that, just as a point of general advice, is if you're doing this sort of work, don't work with things that you can't see, because you can't see what's going wrong, right? So, I've had really good success in the past with just using the laser line from a laser level, because it's visible. I can see what it's seeing and what it's not seeing, and if it's being absorbed or not being absorbed. And then just using a standard cheap old webcam and taking 2 images, one with the laser line on, one with it off, do frame subtraction. You get a very clear line. The parallax between the camera and the laser line angle tells you how far something is. And it's pretty stupid, and it just works. I'm curious, were you able to use the actual voxel data from the RealSense camera anywhere in your project, or no?
Well, so what I do is, in finding the can, as I said, it isolates where the can is in the frame based on color. But then once it's got, you know how it'll draw a box, OpenCV will draw a box around that blob.
Oh, then you're grabbing the 3D data only within that box.
Exactly. And then now the camera is looking down at an angle, about a 45-degree angle. So then I have to do some math to translate that into the world coordinates. And
It
then
turns
once I
out
know what the world,
It turns out that you will use the trigonometry that you learned in high school, right?
exactly. And so I translate that, and then I, have a pretty good idea of where it is in 3D space in relationship to the robot. And then that information gets sent to the arm, which then translates that to its local coordinate system, and then it reaches out. But I was finding that I could never get the gripper to go precisely to where I wanted it to go. So what I do now is I go close to the can, a little back from the can, and then I took that suggestion that you made. I put 2 LEDs on the gripper. And then with that camera, I take a picture of it with the LEDs on and with the LEDs off, do the subtraction as you suggested. Those 2 LEDs jump right out at you. And then I know the distance between the 2 LEDs. I can then calculate where the gripper is in comparison to where I thought I had moved it. And then I can make a last second adjustment, move it. Typically it's a little to the left or a little to the right before it actually reaches in and grabs the can. And I like to tell people when I describe that to them that I gave Gidget a little hand-eye coordination.
Very nice. So I'm curious about one other thing. And if anybody else has a question, just tell me to shut up. But you're using the RealSense 3D data. I'm assuming that you're calling their library or something, and you're getting like an average of all of the depths within that square, or maybe it's min, max, or whatever. That's not my question. The question is, are you looking at both the up and the down to find the top and the bottom of the can? Or are you only looking at the left and the right and assuming the vertical position of the can?
No, I really what I want is to know how far away the can is. I'm not concerned about the height.
It's not the distance. How do I say this? It's not the distance at a specific, because you are using the bounding box, right? So I guess what I'm trying to say is, are you looking at the distance at the center point of the bounding box?
Yes.
Okay.
A smaller square. I figure I'll average a small square that's in the middle
Zoom
of the
in a
bounding
little
box.
bit. Yeah. Okay. So what that means is you're not actually using the RealSense data to find the can, because you're doing that with colors. I mean, you could do that with a regular camera. And then you're only asking for one particular distance, which is the distance at the center of the can, which you could do with your time of flight sensors if they were reliable against the can, or you could do with the laser line. So so the point I'm trying to get to is, every single hobbyist robot that I talk to, every single person who's using this, who has a RealSense camera on there, does not actually use, or at least not need to use, the depth data from the RealSense camera, and with very few exceptions.
So my original intent before I started using that time of flight sensor for the walls was I was going to use the RealSense. I'd also use the RealSense to measure the distance to the table before I put the can there. I was going to use it to measure where the walls were, because I really don't want to do dead reckoning. I'm doing way too much dead reckoning. I'd rather navigate to like the opening of the hallway and then measure where the walls are and then adjust. But the walls are so short. This is a case where in the real world, it would actually be easier. But with such short walls, I wasn't getting good data on where the wall surfaces were. I did some experiments around the house, and I could see the walls in the house and the hallway and stuff really well.
But Lloyd's going to tell us that we're out of time here and we have to get on with the talk. But call me sometime when you get a chance, because I want to argue with you about this for hours and hours on end.
Okie doke.
You guys are right on all cases. We are out of time, and you guys can yes, argue to your heart's content. At this point, I'd like to turn it over to Jon Davis to talk about enhancing software programming productivity with GPT and LLM tools. So Jon, go ahead and just grab the sharing and take it away.
All right. How you guys doing? I have not been a part of you guys, so I apologize if I am a little bit dense on the ways that you guys do things. I know Steven, and I guess he's out, but he invited me to join because I am a software developer, and I told him I have been using GPT and LLMs in general to augment my day job as a developer, and so he invited me to share my findings since last time you guys tackled this as a demonstration. You found that it wasn't quite as helpful as you wished, and there's obviously reasons for that. It was new. So and it's still pretty new, actually. Let me go ahead and share my screen. I'll say this: I reserve the right to be wrong about things as I talk about this stuff. I don't consider myself like an expert on this topic. It's you know, I'm just another consumer of LLM technology to augment what I do, and but it's been a fun journey recently, especially just over the last, I would say 2 or 3 months, trying to catch up with all that's going on, with the way that things are going. How do I hide this top section here? Oh, it goes on its own. All right. So my day job,
Just go for it. Sorry.
My day job is a company called LeaseHawk. They don't know that I'm doing this, so I'm not going to take much time on this, but they happen to do AI as kind of a component of what they sell as a product. And we were kind of doing chatbots before chatbots suddenly became a thing, kind of somewhat intelligent chatbot, where it was database connected. And so somebody trying to sell apartments, they would go in and say, hey, what's your pet policy? And we'd answer that question. They'd say, can I schedule a tour? We'd collect their information and schedule the tour. We'd provide them the pricing on an apartment or whatever, and do all that in a conversational way. Another product that we offer at LeaseHawk is we'll actually listen to phone calls with sales agents and score them. So like we'll have a number of questions that are based on like reviewing the transcript. Like was he friendly? Was the salesperson friendly? Did they schedule a tour properly? Did they provide directions to the all that kind of stuff, so these scoring strategies actually contribute to the salespeople to be able to give them a raise or a bonus. So that's why, and we have been we had an AI technology do that, then we handed it off to humans, and now we just recently got plugged into GPT to get back to AI to do that. And so like we're now able to leverage what we're now all enjoying with LLMs and GPT into our product, and actually make that a component of the product, and do it actually very, very, very remarkably well. So that's just a couple of the things that we do. And obviously with the chatbot thing, with the recent trend with ChatGPT, people's expectations have just skyrocketed on what they want and expect with a chatbot, right? And so like that's one of the reasons why I've been clamoring to catch up on like what is going on out there in AI space, and like what is this stuff? Because I honestly, I got, like, as a developer, as an engineer with Leasehawk, I got behind because we were doing day in, day out, just catching up with this core integrations type of thing, like scheduling a tour with this system and all that stuff, as opposed to this is a whole new AI technology that, you know, we need to pay attention to. So I was probably a year late, even though I was working with AI, you know, 2 or 3 years ago. It was more machine learning and not so much with LLMs. That said, would you guys mind if I took a little distraction, a little detour, and played around with a little bit of things that don't directly relate to LLMs, and I'll circle around back to that. But it's more, I want to share kind of my journey of how I started to get my head around generative AI. And if anybody has a concern, speak up, because otherwise I'm going to plow forward.
I'd say go for it.
Okay.
That sounds great.
So everybody is familiar with the fact that, like, on the news, you see everywhere, like, you got generative AI producing images, for example. So like here, for example, I can say, make a new logo for Seattle Robotics Society, a dancing robot, or something, right? And I give it a moment, and you can see it progressing, 22%, 37%. It's going to make 4 of these. You can see it kind of thinking about it and thinking about it. And then finally, we've got a new logo that you guys can play with. How about that? It's crazy how good this is. And if you think about what's going on behind the scenes, obviously it's got some quirks, you know. There's 2 T's in Seattle. They're working those things out as they go and continue to improve. If you think about what's going on behind the scenes, it's a neural network, and they just load this thing up with just gobs and gobs of samples, and you guys have obviously, I'm sure, been discussing how those get built up. You know, you get 2 samples. One of them kind of wins between the 2 of this is more ideal than that, therefore go in this direction, kind of thing. And that's kind of the way the most basic AI kind of works. You do that with, in this case, generative AI working with image generation. Another use case could be, I'm not going to do this actually, but could be doing a video generation. So I've used this recently, where I was cobbling together a bunch of videos where I could say robot dancing or whatever, and wait around for a couple of minutes, and it'll generate a video. I'll move on. Actually, it's doing a little bit faster than I expected. Might actually be able to see something here. Well, as that goes, here's another use case of generative AI, is Suno. I don't know if you guys have seen this. I've heard of it. Another one is called Udio. But you can say, write a song about robots on the moon. Create. It's going to go off and create some pretty darn cool music. And I had a way I saw earlier to make sure to share sound. It's on there. Okay. See if that video's done yet. 72%.
Silver stars high above, robots dreaming what they love. Metal hearts, yet they bleed. Wires and circuits in a moonbeam.
All right. So you get the idea. So it created lyrics, it put it to music, it sung to it. And then go back over here to video. It's still at 87%. There is a video coming. So, and these are just applications of generative AI. Again, we've got the idea being you take many samples, and then you create a scenario. Say, I want you to produce based on what you know, and it takes what it knows and applies your application. Here's the video that it produced. We had robot dancing, and it's barely moving its little fingers. Got dancing water in the background. Well, it was a shot. This is actually a weakness of Runway ML. We got this new thing coming up called, what is it, Sora? I'm going to pull up a video here, and you guys may have seen this, shared it. It's another 2-minute papers one. This one really kind of was the beginning of everything for me, as far as all things AI. So if you guys don't mind, I'm going to play about half of this, and just pay attention to a couple things. I'll get into it in a minute here.
OpenAI built a hide-and-seek game for their AI agents to play. While we look at the exact rules here, I will note that the goal of the project was to pit 2 AI teams against each other and hopefully see some interesting emergent behaviors. And boy, did they do some crazy stuff. The coolest part is that the 2 teams compete against each other, and whenever one team discovers a new strategy, the other one has to adapt. Kind of like an arms race situation, and it also resembles generative adversarial networks a little. And the results are magnificent, amusing, weird. You'll see in a moment. These agents learn from previous experiences, and to the surprise of no one, for the first few million rounds, we start out with pandemonium. Everyone just running around aimlessly. Without proper strategy and semi-random movements, the seekers are favored and hence win the majority of the games. Nothing to see here. Then, over time, the hiders learn to lock out the seekers by blocking the doors off with these boxes and started winning consistently. I think the coolest part about this is that the map was deliberately designed by the OpenAI scientists in a way that the hiders can only succeed through collaboration. They cannot win alone, and hence they are forced to learn to work together, which they did quite well. But then, something happened. Did you notice this pointy, doorstop-shaped object? Are you thinking what I'm thinking? Well, probably, and not only that, but about 10 million rounds later, the AI also discovered that it can be pushed near a wall and be used as a ramp, and ta-da! Got him. The seeker started winning more again. So, the ball is now back on the court of the hiders. Can you defend this? If so, how? Well, these resourceful little critters learned that since there is a little time at the start of the game when the seekers are frozen, apparently, during this time, they cannot see them, so why not just sneak out, steal the ramp, and lock it away from them? Absolutely incredible. Look at those happy eyes as they are carrying that ramp. And you think it all ends here? No, not even close. It gets weirder, much weirder. When playing a different map, a seeker has noticed that it can use a ramp to climb on the top of a box, and this happens. Do you think couch surfing is cool? Give me a break. This is box surfing. And the scientists were quite surprised by this move, as this was one of the first cases where the seeker AI seems to have broken the game. What happens here is that the physics system is coded in a way that they are able to move around by exerting force on themselves, but there is no additional check whether they are on the floor or not, because who in their right mind would think about that? As a result, something that shouldn't ever happen does happen here.
Right.
And
so you get the idea. This almost self-reinforced learning approach with AI is basically the bot teaching itself, which is actually really cool. And it's using it's leveraging physics, in this case, flaws in physics in the physics engine to kind of cheat. But did you pay attention to who this was? This was OpenAI. And so like when we're talking about ChatGPT, it's the same company, and they were taking they're obviously they're thinking through similar problems when they're dealing with working with LLMs. So I want to just expand on this idea of where we had some simplistic mindsets about just taking multiple chat entries and confirming which one is comes after the next and saying yes, that's the best way. It actually is much more involved in that when you have computing resources reinforcing those scenarios. That was 4 years ago. And if we fast forward to just a year ago, here's another video.
It is time for random perturbations. What does that mean? It means that forces are randomly exerted on the AI to make sure it can recover from an impact. And are you thinking what I am thinking? Oh yes, now let's go to the real robots and let's test that impact. Oh, that is not very nice. But then, wow, look at that. What it had learned in a simulation now really applies to a real-life robot. It can get hit and is able to get up over and over again. My goodness. But there is a problem. What is the problem? Well, their knees get injured all the time. So, what did scientists at DeepMind do with that? Well, hold on to your papers, fellow scholars, because they taught the robot to get up and move in a way that is not too hard on the knees. Yes, that's right. And thus, they didn't suffer that many knee injuries. What a time to be alive.
All right, so the idea is they're actually applying it to the real world physics. You can see these robots literally playing soccer. How do they do that? They actually applied it from simulation over and over again, and then brought it into the real world, which kind of demonstrates that the simulation got good enough to get practical. And right now, this is more you guys' world than mine, because I don't really deal with a whole lot with robotics. But as I believe, like NVIDIA has really been pushing. They've got this virtual world where you can program robotics and stuff with very, very realistic physics, and a lot of people are learning how to build robotic applications using their simulation. And anyway, this is not OpenAI, but I just wanted to share about how that was a demonstration of applying this machine learning into the real world and going beyond to terribly simplistic approaches, and actually being very practical. But with regard to generative AI, it's basically all about output. And the reason why I went through all that stuff is because it's all about output. You get, just to speak to it very simply, you get gobs and gobs of data. You end up with the proper computing, and you end up with output. And by the way, guys, I kind of had to clamor to get this stuff prepped. So if I struggle to get my words out right, there are reasons I actually would do a little bit better if I wasn't overwhelmed with some other stuff going on. So with regard to what we were doing about 3 years ago, we were doing something like Dialogflow. And just to rewind a bit, again, I was talking about my journey, where I came from as building these chatbots. Dialogflow kind of lets you build a chatbot. And so I took about 3 minutes to cobble together this Dialogflow agent and to try to demonstrate this. And it comes out of the box with a welcome intent saying basically, hi, how you doing, whatever. And then if it doesn't understand you, it would say, I didn't understand that, whatever. And then you can add your own intents. So I put in here a custom intent saying, if I say bot or if I say robot, then it would say, oh man, I love robots, right? So if you come over here to the right side here and I say, hello, I don't know if you guys can see this. It says, hi, how you doing? I'm fine, how are you? It would say, I don't understand. Could you say that again? If I say, are you a bot? And it says, oh man, I love robots. And so like, that's basically an example of a very, very simple example of how some of these earlier chatbots used to work. And we kind of built on a framework similar to this, a little bit more complex than this. Down here below, you can see that there's a mechanism where you can enable fulfillment, which actually calls a backend. And on that backend, you can do things like call an LLM or do other things. And of course, we were doing that to integrate with our database. So now that so the approach here is really you're building a smart-ish flow diagram as your chatbot. And so a lot of these existing chatbot creators tools out there are kind of built on these flow diagrams. With modern LLM tools, though, it's no longer kind of this basic machine learning. So this training here, bot and robot, those are really simple machine learning techniques. You get you feed in these training phrases, and it'll do sort of it'll make a best guess based on usually more like spelling and pronunciation than anything else. This is where things completely deviate, and I'll get into this, but with the LLM, it's less about spelling and pronunciation and more about semantics. So, for example, a cat versus a feline kind of mean the same thing. And so it goes out there into this virtual space, this three-dimensional vector space, and numerically maps it out there. And so that's how it knows when you say cat, it knows you're talking about a cat or a feline or something like that. So this being my world 2 or 3 years ago, imagine my surprise when I came across this. This is how I first came across GPT. So it was this interface. This was actually before ChatGPT came out. And I didn't know what it was. I just knew everyone was starting to talk about it. And I said, I went in here and I said, how do you describe I don't know, apartment complex. I don't know, just a random thing. And then I'm watching it output like rich detail right in my face. And like, wow, like I've never seen this before. Like, how is it? No. And then I dabbled with like format something in a certain way, and then I would have a dash dash, and then here's an example. And and I was amazed to see that it actually understood where I was going, even though I had the dash dash. Because in my world as a programmer, I'm used to having to deal with parsing, like meaningful parsing. Like at best, I would have to do a domain specific language to parse out exactly what's going on. Again, guys, I'm going and rewind here. I know that you guys are familiar with all this stuff and what it's doing, but I just wanted to embellish on this journey. And of course, the way that this system works here, you can specify a system instruction before you input the user instruction, and then it outputs the assistant result. But this playground originally was an interface for you to discover how to use their API. And when you use their API, you can then integrate it into your application. So ChatGPT, and this is GPT, but ChatGPT, which is this guy, is actually an application of the GPT API. And what it does differently, among other things, is it retains the history of what you've said so that it gets spoon-fed with into basically as part of the system prompt, system message, before you then interact with it. So if I say, hi, my name is John, and it says it's going to come back and say, hi, John, whatever. And then if I say my last name is Davis, very, very simple demonstration where it remembers my first name. Got it, Jon Davis. So the way, again, it does that through basically stuffing your history items into a payload with your message. And so I wanted to get into, sorry, excuse me, guys, for 1 second here. So I wanted to get into
enjoying the live element to this presentation. That's really nice.
And how's the live element?
Well, you know, just that it's real. You're not. It's not like just a canned presentation. You're actually using the stuff. So
sure.
The little pauses or whatever are great.
Yeah. Thank you. So I actually did try to ponder how I could can stuff. I'm like, I do not want to do that because we want to make it real. And see this how this comes into how this can actually change our flow, right? Directly. ChatGPT is not the only player, obviously. You got other LLMs. Another one that's very popular, and dang it, this toolbar got in my way again, is Claude, as an example. Let's try to log in here. Claude, they've got a number of LLM models. One of them is Opus, and you'll hear people talking about like Sonnet and Haiku. Those are all V3 versions of or V3 generation of their interface, and it's basically the same idea. They've got an LLM, and you can say, what's the weather typically like in Seattle, and it's going to probably talk about the rain, right? It's the same idea, and so. But different people have different experiences between OpenAI versus Claude, or the company that hosts Claude. My brain just went Anthropic. Sorry, that's the word I was looking for. Anthropic. So OpenAI versus Anthropic. So they've got different approaches to managing the LLMs. OpenAI, they're leveraging the LLM as into GPT as an application of an LLM while adding more to it. So for example, if I go back to ChatGPT and I say, what is this, this big ugly number plus this big ugly number? Okay, I think we all know that LLMs do terribly with math. But it's probably gonna get this right. You'll see this instead analyzing at first, and then it outputted a result. How did it do that? Well, actually, it wrote a Python script, and so that's where you'll get into examples, or if you look at setting up GPT Assistant, you can turn on a toggle of whether or not it runs runs code. You're allowed to run code. So in this case, it figured out that in order to get this correct, it can't rely on the LLM architecture. It has to rely externally through something that's more suited to the task of doing the math. And so in this case, it generated a Python script and it allowed the Python to do its thing. I could have it, I did this earlier. Can you please describe in detail how you came to that conclusion? And it could actually break this down into aligning the numbers and doing basically carry the whatever. I did this previously and actually went into more detail, but you get the idea. So it is interesting how it actually thinks about the problem to solve, and then it solves it while not completely relying on its own weaknesses. This is the approach that OpenAI is taking. And so if we rewind again, and we think about how we were defining LLMs and the way that they were created as simply multiple ingestions of interactions and giving human verification of this is better than that. If we expand on that, so A, B, C, D, E, what follows E? F, right? Okay. So once, if I'm writing a fictional novel, right? Once upon a what? Time. So with it, we know that generative AI is built to produce a prediction on what comes next, and that's how all of this works. But it's become more complex than just letters, obviously, and now more complex than words. When you have billions and billions of pieces of data cobbled together, and every word and every collection of words is mapped out into vector database space, and not just in one like three-dimensional space, but about more like 1,000 or two or more dimensions in this space. What you're doing there is you're allowing this, you're mapping out concepts. You're no longer mapping out just words, you're mapping out concepts. And so as a concept, if it rains outside, then I expect what to happen to the ground? I expect it to get wet. And so that logic will come because it's an expectation of what's to follow. So if I have this problem, then I expect a solution to be what? Well, it figures that out by way of X follows Y. It understands concepts because it's mapped out significantly more complex concepts through the use of words, in this case, in the case of an LLM, mapping them out into multidimensional vector space, and then reaching a conclusive expectation of what follows. That's how we end up with the concept of reasoning in an LLM. So it is actually getting much closer to human-like thinking than we were giving it credit for in years past. And the reason why we didn't see that, somebody put it this way, I think it's a real simple concept. It kind of shifted my world. Is think of, I mean, it's just obvious fact. Think of ChatGPT or GPT 3.0, 3.5, 3.5 Turbo as the little toddler has finally become a 12-year-old. With GPT-4 and now 4.0 Omni, it's now become a teenager. And you think about how a child grows up, like a 2-year-old barely knows how to talk. And you could say like a 2-year-old behaves quite erratically when it comes to like processing language. And that's what we were seeing 2 or 3 years ago with some of the earlier versions of ChatGPT. And you could make easy conclusions about how that thinking comes, where that thinking comes from. It's obviously not doing a whole lot. It's just basically taking simple inputs and outputting whatever. That's you could say that of a 2-year-old child. But as it continues to progress, we can see it actually getting significantly more sophisticated in how it handles recognition of patterns, patterns of concepts. And I don't get me wrong, it is still very, very young, and maybe it's giving it way too much credit to say it's like a teenager now, and maybe more like a 9-year-old now. But the fact is, we still have a lot to look forward to in terms of a future. And if we don't have a future, then might as well all go home, right? So it's actually pretty exciting where this is going, and frankly, a little bit scary. I'll be honest with you, because it means we have to be paying attention, and we need to, like for my career path, I need to make sure that I know how to leverage AI everywhere I go. Not just in how I maximize my productivity, which I'm going to get into here soon. And I've already gone over what I was planning on to get to that point. But but also being able to bring that in as I was showing here in this playground, and how this playground demonstrates how you might integrate with an AI or API rather, bring that into whatever solution you're building. Which means that as you guys are building robots, for example, you're building something that runs on 2 wheels. It's reasonable now, as if it has Wi-Fi on it and has enough computational power on it, to send API calls back and forth to OpenAI. OpenAI has its own speech detection. So you can have it do speech to text to listen to what someone outside is saying and convert that to text, as well as text to speech. So it can talk back to you. All of these are exposed via APIs. So you can have this little microcontroller, or I should say like a Raspberry Pi or whatever, rolling around, but also now be able to talk to you very, very easily. I'm not going to demonstrate that, but the point being that's available to you. And it's actually able now to be quite coherent as you spoon feed. Remember, I talked about the system message preceding the user message. You can spoon feed information about the context as you go, so that the coherence in that interaction can be made relevant to that robot's surroundings. For example, as we're applying this technology into our existing bot, we need to spoon feed apartment information. What's the pet policy? What's the leasing policy? How much is rent? All that stuff before we allow the GPT to respond to the user. And we do that in a way called RAG, and I'll get into that in a second. And then it'll have enough information it needs to be able to respond in an intelligent way relevant to the context. In your case, you might spoon feed a picture about what it's seeing through the camera, a little bit of information that this is a bot that's sitting on the floor, whatever. If it's on the moon, you could say the gravity is whatever 0.2, whatever it is, versus Earth. And there's a hole up ahead or whatever. So like, obviously it's not going to be able to do text to speech out on the moon, but not going to get real far unless you've come across some aliens out there. But maybe Mars will be different. Point being, you guys can get creative, and I assume that some of you guys might have already done some of that. With regard to, let me also talk about these LLMs. So the LLMs right now, OpenAI is the leading provider of LLM hosting with GPT, but there are other LLMs out there. You've got Hugging Face, which actually is hosting a number of open source LLMs where the whole community is contributing to these different models. Ironically, OpenAI is not open. It's anything but open, similar to Claude. So there's a lot of open source LLMs that you may want to defer to if you want to get outside of the ecosystem of OpenAI. When you do that, you get into different kind of hosting scenarios. Here's an example, Grok, which I thought was really interesting because they're taking the computing of processing LLMs, similar to how you would process LLM computing, I'm sorry, I forgot the word, but basically the inference computing. When you say something, what does that infer? So that finds that out in vector space or whatever and correlates that. So that's inference. That computing process, similar to how you would use a GPU to accelerate that, they built their own hardware. And so like Grok is ridiculously fast. It's faster than using a GPU. So I can come in here and say, describe what a robotics engineer would Say in as many words as you can and watch how fast this thing outputs. Boom, it's done. That's how fast it is. 1,200 tokens per second. So that's fast. I mentioned earlier the issue of using well, maybe I didn't mention it. There is a problem you have with LLMs called the token window, the context window. And basically what this is how much can you preload the LLM before it can process your inference. So in this case, it's what I was doing here was 8K, but some of the earlier models were more like 4K. In the case of GPT, it's, I believe, 120K, GPT-4o. In the case of Google, it's right around 1 million as the maximum. So what we're talking about is how much data can you spoon feed into, for example, the system prompt, or how much history can you maintain? Because it's all the same difference. How much history can you maintain in a chat conversation before it starts forgetting and before it starts basically running out of memory? Think of it like buffer space. It's more than that. It's more than buffer space because it actually has to think about and reason about all of this payload that you've given it. Every single word has to be accounted for. Like this meant that, and that meant this, and these concepts are then mapped out and comprehended in a sense before it comes to a conclusion on what it is you're trying to say and what the result is. So if you simply say, how much does it cost, and you don't provide any context, it's not going to know what you're talking about. But if you provide a menu, then and then it processes how much does it cost, then it can provide that context. If the menu is a gigabyte in size, that may exceed the context window. So we measure some of these GPTs in large part by size of that context window. So when we're talking about tokens are basically, think of them as words. How much a word or a small phrase consumes and so like that's your token window. So when you have 8K, you can only have 8K worth of input before it gives up and it can't handle that much data. That some of that token window, I believe, is also consumed in processing the result. So be aware of that. But that said, you can host the open source models on your local machine. And so that might close the gap some of you may have with regard to, I can't run generative AI of any kind in my workplace because we can't let these payloads go out with our code base or with our samples or whatever as RAG data, which is what that RAG is what we refer to when we talk about preloading information, inference information. In fact, here's a little diagram of that. You send your query, but you basically check the vector, a known vector database on what it is that you're talking about so that you can include with your query some relevant information. Not everything in the world in your world, but at least some relevant information about what you're talking about so that you can augment your prompt with what it is you're querying. And it'll come back with the result based on that context. When you do that, you're not going to overload the context window. If you isolate to the embedding, to whatever vector database embeddings that you have, based on its basic. So as you provide your query, it's think of it like an utterance, kind of like how in Dialogflow I had this training bot and robot that may map out here to, oh man, I love the robots. Well, what if this text response was actually a document, a full-blown document? So it could spoon feed that whole document and pass that on to the LLM, and the LLM then has enough information to work with in order to customize and tailor a response. Augmenting, what it's augmenting it also is its existing collection of millions and millions and millions of other broad data that it already has in order to build a coherent response. So that augmentation, some people don't want to send that out over the network. They just want to, if they want to do that, they can do it locally. They can do it with something like this, Ollama. So Ollama is something that can allow an LLM to run on your machine. So as an example, Ollama run Llama 3, and that's going to spin up Llama 3. And I'm running this on my local machine. And Llama 3 is what Grok was using when I showed you Grok. But I can say, hello, what is 2 + 2? And it's going to think about that. And you can see how slow this is running on my local machine, but it produced a result. So think of it as a little programming language, but the language is English. And sometimes that programming language runtime is smarter than the next guy, depending on which model you use, faster or slower, depending on your hardware, etc. But you can run that locally. So that's something you can consider as Ollama. There's another one you can use called L Studio, and I have that running here as an example. So like this, basically you can choose a model to run with and then test it out here. You can also have it hosting the LLM in memory. Ollama does better than LM Studio when it comes to hardware acceleration. I don't know why. I just heard people whining and complaining that LM Studio seems to be struggling with some of the GPU acceleration. You can still use, by the way, you can use GPU to accelerate. You don't have to use like Grok's custom hardware. It's just not as effective as Grok's hardware. And frankly, Grok, they haven't sold their hardware. Meanwhile, NVIDIA is also building new boards, new cards that are LLM specific to also accelerate. Man, I did not rehearse this, so I didn't know how much time I'm going to be blowing through. But so I'm going to link these real quick, and so that you guys can have that.
Hey, John, I'll do a shameless plug for Steve. You're always welcome to come back and do another one.
Sure. So there's Ollama, and as soon as this thing goes away, there we go. Get LM Studio. I also shared about, for fun, let's do ideogram, runway, Suno. I shared this video about how AI this is again, I want to point out OpenAI was doing that video game AI there, which is the same, obviously, or the same organization as doing ChatGPT. So you can think about where their mind is and how they're tackling video about the real world robots playing soccer. If you're curious about building a bot with old school tech, here's dialog flow. Get rid of some of this. There we go. I want to talk about development tooling. We might all be familiar with GitHub Copilot. So I like to use Visual Studio. We use Visual Studio in our job because we use .NET. Copilot, GitHub Copilot integrates well with Visual Studio. And it's basically you have very, 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 very smart autocomplete as well as integrated chat. You guys were demonstrating earlier about how if you query for code, you can generate code, and you can actually attach a file that is your code and have it inspect that file, and it can do a diagnostic and look for bugs or an enhancement, whatever. I've done that many times now, and it's actually very effective. GPT-4o and GPT-4 Turbo approach those problems differently, and 4o is usually better. It's definitely faster, but sometimes you may have to switch down to GPT-4 Turbo. I expect the next model to be significantly better. Another one is Tab 9. Tab 9 integrates with Visual Studio as well. I also use Visual Studio Code. So these things do work with both of those, Visual Studio Code, some of the other IDEs that are out there as well. community is always building up these other tools where they integrate GPT and other LLMs with the coding environment. Another example was 16x Pros. I'd never tried this. I was just curious about it. It's very beautifully boring interface to kind of spoon feed your scenarios and have it kind of help you drive. This is another use case of I just wanted to show this one off of generative AI kind of taking LLM plus diagramming and putting that together. So I could say, show me a flow diagram of, I don't know, a bot that walks around. I have no idea what you might diagram, but if you watch, that was not expected because it was doing this earlier. Generate. Oh, I've used up my 5. Well, it would have been cool if it would actually, okay. Let me look at some of these other ones I've done. So here's an example where I said, I talked about RAG. So RAG being an example of where I start here. This is actually not a valid output. Let's try this. Here we go. I literally wrote a robot arm control sequence. That's what I inputted. And this is what I outputted, all on its own. So you have controller and sensor, motor, and arm. Starts off, initialize motors, sensor's ready, activate motor, move to start position. And anyway, and then it goes into this loop, continuous operation. So I thought that was really cool. So here's the URL for that. Let me get back there. That would be really useful for thinking through, thinking through a problem and getting it diagrammed before you start or whatever, right? Example is Plandex. I actually have not had a chance to use this, but I believe this is going to be an example where you're kind of working out of a console type of interface that will plan out your strategy and output your code. But what I've currently been using is Cursor AI. Before I get into this, let me also talk about agents. So I talked about RAG, but where everyone is going right now, if you guys are not familiar with agents, you might want to get familiar with it. And the idea is agents are basically the idea of, first of all, we know that our context window is limited. And we wish that we could just hand a large problem to an LLM and have it come back with everything that we want. But if we were to allow the LLM to just break things down into a sequence of what we need, and with each item in that sequence, we spin that off to let an independent component handle that problem. And then the next item, let an independent component handle that problem, etc. And we complete all of these tasks together as one set of tasks, as one unit of work. That loosely describes one use case of what an agent is. And that the idea is you're rewriting Python or some other code to organize and manage sets of tasks that you're relying on the LLM to do. And then when it completes all of those tasks, that completes a unit of work. And so some of those tasks can be to come back to execute an integration. I didn't talk about how OpenAI supports the ability to do a callback. So you can add tools into your system, your GPT, as an API integration point, so where you can say, hey, if you need this tool is available to you. And so you basically describe a function. And so the LLM will take the user input and say, okay, you know what? I can't provide the solution to this question until I run this tool that was provided to me. And so it'll come back and say, run this tool for me. And so you run the tool and you spit back the results, and then it'll continue with handling that result. So that could be, for example, an integration point. In that scenario, your LLM, GPT, whatever, can actually do things like, oh, I don't know, servo control. It could do all kinds of fun stuff, right? You can do all kinds of integration points to that. So I'm hoping you guys are hearing me. I don't have a chance to demonstrate visually because I'm running out of time. But I just wanted to clarify, like agents will also do that, but that's a scenario what I just described is where GPT is actually also running as an agent, not just as an LLM. You saw earlier how it generated Python and ran it. That's a scenario where GPT, being an application of an LLM, is actually an agent. But here is an example, Cursor AI is an example of where it actually integrates LLM and agents into the IDE. So what they did is they pretty much they literally cloned Visual Studio Code and decided to create an AI-enabled environment. And so I might come in here and I might say, first of all, let's say I wanted to make a game, right? C dev, oops. I want to make a game. We got 5 minutes left. Let's see how far we can go with this. So I go in here and I say, it's built-in chat and it's using a model here. I don't know if you can see my screen well enough, but it's right now it's set for GPT-4o. I could choose GPT-4 or one of these other ones. But I might say, let's make a game and I want to actually build it out. I did this earlier. What game would you guys want to build real quick? Let's see how fast we can build this thing in 5 minutes or less.
Build a robot simulation.
That's what I was afraid of. I was afraid you'd go there.
I was going to say start at the beginning. Pong.
Pong?
Actually,
Okay.
Pong's not a bad robot simulation.
Yeah.
I'll tell you what, before I get in there, let me show you what I did in prepping for this just yesterday. And this took about 1 hour. And so if I run terminal, everything here was spoon-fed to me. This is Frogger. So I've got the little green guy at the bottom. And everything was spoon-fed to me. I mean, I had to deal with problems, you know. First, I mean, one step at a time. First, it created these things going back and forth, and then there was no game over. There was no approach. I had to tell it, okay, first of all, you got red blocks kind of overlapping each other. They're all going in the same direction. I had to create 2 lanes. And I could show you that history, but I'd rather not bore you. But that's the idea. In fact, actually, I might be able to pull up some of that chat history. No, if I kept this window open, it could actually remember those old chats. Yeah, so let's try Pong, see how fast we can get to that with 3 minutes remaining. Yeah, right. Okay, quick, but we need something complete. 2D, color window with mouse support. All right, so it's going to tell me pip install Pygame. So pull up a terminal, pip install Pygame. Got some space here. All right, create a file called Pong. So I'm going to do that. Pong.py and add this code. So what I'm going to do is apply it to my current file. It's going to do that for me. So it's literally copying this stuff straight over. I hope I didn't cut it off. Nope. So it's green because it's waiting for me to approve. I say yes, accept. And so now I can just say Python Pong. See what happens. Oh, I didn't save it yet. That's one of the downsides is I keep forgetting to save. It helps. Always helps. That's what it built for me already. There's actually not much to improve on. So there you go. It already knew. And of course, this is an example. I mean, I saw you guys' presentation from last year. This is an example of what it kind of knows out there, kind of regurgitated what it knows about. But let's say I wanted to change things around. Let's say I want it rotated 90 degrees so that it's horizontal movement, right? So it's going to just generate the changes that are needed to do this rotation. Again, how's it doing? It's thinking through the problem as a concept rather than a set of words, and it's regurgitating the expected result of the problem to solve. It does that better each generation, anyway, that I just want to give it credit where it's due, even though we all, as software engineers, we want to be real, right? It's not thinking like a human, but it's closer to like neural network mapping, whatever, is closer to human thinking than we might give it credit for. So I apply those changes. You saw that it actually injected those changes. If I undo this, it injected the changes as a diff, which is really cool. And I can approve these one by one if I wanted to. You can see Control-Shift-Y here, or I click on approve that. I don't like that, or whatever. I'd reject that. That's actually really, really handy if I could see what it's generating. It's not what I want, whatever. But if I accept this change, I save it. We're out of time, but I just want to try this out. And it's actually now vertical. It's like, seems to be I'm on the top instead of the bottom like I expected, but there you go. So it did solve that problem. When I was doing the Frogger thing, I did run into issues where it kept producing a bug, and I kept saying this bug exists, and it would kind of say, okay, let's fix that. Here you go, and the bug remained. I said, it's still a bug. It said, oh, you know what? You need to do this. So and literally nothing would change. So is it flawless? No. There's a couple approaches I did to fix that. One was I would shift back and forth between GPT-4o and GPT-4. Another approach is I would just start a whole new chat. And one thing about this cursor.sh is if you hit Control Enter and you have a large code base, it will actually capture all of your files, package them all up, all of them, and push them out to GPT as context. So that if it's a very large project, that'll use up your context window very fast, get a little lost. But if it's, let's say 10 files, 15 files that are, let's say 100 lines of code each, it won't get lost on that. And so that actually is really, really handy and useful for giving it a fresh view of your project. And so you may need to like create a whole new chat if it gets stuck on a bug. One thing about these GPT chats is once it's gone wrong, it tends to stay wrong if it doesn't correct itself immediately. And like if you're working in the sandbox window, you can kind of go up and correct it once you figured out the solution. But if you don't get that corrected, you may have to start over on the chat. That's an issue universally. You guys are familiar with the term hallucinations. Hallucinations get way worse once it got it wrong, and it retains that in its chat history because it sees that as a pattern and it's self-affirming. Does that make sense? And so if you start a new chat and say, just give it the benefit of doubt of a clean slate, here's my context, let's go at it. Oftentimes, probably 3 out of 4 times, that'll actually fix it. Otherwise, sometimes changing the model will work. But again, I've run out of time, and I would so love to keep doing this, demonstrating more examples of how I've used these tools. But I would say one more thing is the majority of my use cases where I'm actually utilizing any of these LLMs is really the classic approach. I go to ChatGPT, I go in here and I attach a file. I might attach either my actual, like a JavaScript file, complex JavaScript file, or I might actually zip up the entire context of my project. And my instruction is unzip the entire file and inspect my project for context. If you don't give it that instruction, it might ignore you. But once you've done that, and then you explain what your problem is and what you want it to do, you might also say be meticulous. Go over each file step by step. Because if you don't say these kinds of things, sometimes it'll try to gloss over it and give you a quick and dirty, simple predictive generation. But when you tell it the instruction, I mean, it has to try to obey you because that's the instruction. So those things actually really help with using these things when it comes to glossing over and skipping details. So I hope that helps you guys. I'm sure it does. This might be like review for a lot of you, but this is kind of become my world lately. And I think I'm gonna stop here.
Great talk. Thanks.
Yeah, thank you very much.
This has been very cool. Yeah.
Yep. So I
Awesome.
I actually need to run myself here. Do folks want to hang around and chat longer? I can pass the host function to someone and go from there, or we could wrap up the meeting. And John, yes, thank you very much for the talk, and feel free to, get in touch with Steve and do another one if you'd like.
Sure, yeah.
I have to go soon, so I can't take on the host function, but I do have a couple of questions. If somebody else does, I'd love to ask John a couple more questions.
Sure.
Okay, I'll tell you what, does someone want to take on the host function real quick? I'll stop the recording. Let's do that.
Oh, wow.